Algebras. Welcome to your Chapter 10, Lesson 1 notes video. Before we get into Chapter 10, Lesson 1, I would like to just do a quick overview of what we will see in Chapter 10. So we are going to solve quadratic equations more, but this time we are going to solve quadratic equations that are not necessarily factorable. Turns out there's other ways that we can approach solving our quadratic equations, okay? Because not all of them will be able to factor easily, or maybe they are factorable, but it's stuff that we can't think of off the top of our heads. So we have other methods that we can use to solve quadratic equations. Those two methods are called completing the square and quadratic formula. Now, we're going to break those into two pieces, being lessons 1 through 3. We'll solve quadratic equations by completing the square, but we need to kind of practice first before we get into the whole deal. And then at the end, we'll start talking about solving quadratic equations by using the quadratic formula, the greatest formula in existence, and kind of look at, can we look at our quadratic equation and know whether it's factorable or not and know what type of answers we're going to get? And then, of course, revisiting solving quadratic word problems. So here we go. Let's start talking about what it would mean to complete the square. Now, we know the standard form of a quadratic equation is ax squared plus bx plus c equals 0, where a has to be there. Okay, it has to be some number that's not equal to 0, because to have a quadratic equation, you have to have an x squared. Okay, you have to be an x squared term. Now, what I'm going to do is I'm just going to show you when I take a binomial and square it, what I get. And we talked about this back in Chapter 6, where when you have a binomial squared, you want to rewrite it out into the two binomials that are multiplying together. And you want to FOIL it out. So x times x is x squared. X times negative 7 is negative 7x. Negative 7 times x is another negative 7x, and negative 7 times negative 7 is a positive 49 at the end, which means that x squared minus 14x plus 49 is the trinomial that results from this binomial times itself. That means this trinomial right here is what we call a perfect square trinomial. It's the trinomial in which let's get rid of in and say trinomial is one which results from multiplying a binomial times itself. So a perfect square trinomial is the result of taking a binomial and multiplying it by itself. Now, as a result of that, there's a couple things that we're going to know. The front number and the end number are going to be perfect squares, because they're going to be multiplied by themselves here when we FOIL. The f and the l in FOIL, that's what's going to happen. Another thing that we're going to know, this end number is always going to be positive, because a negative times a negative is going to give me a positive number out here, and a positive times a positive would give me a positive number out here. Okay, so things that we can go into this kind of knowing. All right, the other thing that we know is that if we have a perfect square trinomial, it will factor to become the binomial times itself. So we'll have that already. So actually, that's going to be why we use these, but we're going to need to create these perfect square trinomials if we don't have them already. So we're going to learn some examples of how to do that. So first, let's look at some perfect square trinomials, right? And let's take them and factor them down into the binomial times itself that they came from. So we'll start here. X squared plus 2x plus 1 can factor to become, let's think, what are the factors of 1 that add to give me 2? That would be 1 and 1. And of course, the signs will both be positive because the n number was positive and the middle term is positive, so they both have to have been positives. That means that since this times this, that's the same value, you can write it as x plus 1 in parentheses squared. Let's try the next one. X squared plus 12x plus 36. What are the factors of 36 that add to give me 12? That would be 6 and 6, both positive again, because if the end term is positive, these are the same sign and it will be the same sign as the middle. So again, I get to write this binomial as x plus 6 in parentheses squared. So that's the binomial times itself. Okay, notice again, it comes from FOILing, so I got that middle term, right? Even though it looks so tempting to just square the front and back, we know that the O and the I in FOIL mean there's going to be that middle term that exists. Okay, x squared minus 18x plus 81. What are the factors of 81 that are going to add to give me negative 18? So 9 and 9. And this time, because the middle term is negative, both of these are going to be negative. The end term is positive. They're the same sign as the middle. Last one. What are the factors of 16 that are going to add to give me 8? That would be 4 and 4. Oops, I forgot to write this guy as the binomial squared. My bad. There we go. Again, both negative because end term is positive, so these guys have the same sign, and it is the same sign as the middle. And now we write it as x minus 4 in parentheses squared. So if we have a perfect square trinomial, we get to write it as a binomial times itself, or one binomial squared. That is going to be important in lesson 3. Okay? Well, what if you don't have a perfect square binomial or trinomial, but you want to? Here's how you make one. The formula to create the end number, making a perfect square trinomial, is take the middle number, the b term, divide it by 2 and square it. Okay, that's it. That's what we do. So we're going to take that and do that. The middle term here is negative 16. Take negative 16 and divide it by 2. What do you get? Negative 8, right? So what's negative 8 times negative 8? Positive 64. The middle term here is negative 2. Take it and divide by 2. What do you get? Negative 1. Negative 1 squared is positive 1. Now that's a perfect square trinomial. Perfect square trinomial, perfect square trinomial. Let's do another one. Negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. There we go. Notice I'm always adding that term at the end because, always adding that term at the end because even a negative squared, a negative number times itself, is a positive result. So this addition to the end, the C term, will always be positive. Okay? Let's look at some more. More examples of this. So let's make this a perfect square trinomial. 16 divided by 2 is 8. 8 squared is 64, plus 64 at the end. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9 at the end. Negative 24 divided by 2 is negative 12. Negative 12 squared is positive 144. Now, what I'm also going to ask you to do on the homework is I'm also going to ask you, once you've got that written out, why don't you write this back into the binomial squared it comes from, right? And what I'm going to point out is that, let's think, what times what gives me 64 but adds to 16? It's 8, right? What was the b term divided by 2? What's 16 divided by 2? It's 8. And that's exactly how you know what this binomial squared will be, what the number in the back will be. Take this for example. What multiplies together to give me 9 but adds to give me negative 6? It's negative 3, right? What's negative 6 divided by 2? Negative 3. One more time to prove my point. What multiplies together to give me 144 but adds up to negative 24? 12. But again, that 12 is going to have to be negative. And what is negative 24 divided by 2? Negative 12. Okay, so pause it. You try these to fill in the blank to give me that C term that makes this trinomial a perfect square trinomial. And then I want you to write it as the binomial squared it can factor back to be. Okay? I want you to do both of those things. So pause it right here and then give that a try, and we'll talk about what's going on at the very end here. All right, again, pause it right here. Give those a shot. Okay, how'd you do? Check your answers there. Make sure that you have both the number at the end correct and the binomial squared correct. And I just want to point out 64, 9, 144, 16, 25, 49 are all perfect squares, which makes perfect sense because you're taking the middle number, dividing it by 2, and squaring it to insert here. So now we run into a bit of a conundrum, which would be, okay, if you're taking the b term and dividing it by 2 to get the thing you squared, well, not all numbers evenly divide by 2. So what happens when you get an odd number in the middle? Now, you're not going to encounter this very often. And when you do for now, it's going to be a bonus. But this is something you'll have to deal with in Algebra 2 later on. Okay? And what's happening with that odd number is you still take it and divide by 2. But because you can't evenly divide by 2, leave it in a fraction and just square the top and bottom, which means you're always going to have 4 in the bottom if an odd number is divided by 2 and then squared. You're always going to have that because 2 squared is always going to be 4. So you already know what this denominator will be. All you need to do is square the odd number, which negative 3 squared is 9. So 9/4 is the term that would now make this a perfect square trinomial. It also means that this can still become 2 binomials times themselves that are the same, so 1 binomial squared. It's still figured out the same way what that number is in there. You just take the b term and divide it by 2. That's going to be the value in here. So the value in here is actually x minus 3/2. And yes, leave them in fraction form so you can see that pattern. Okay? Again, just bonus for now, something you'll have to do in Algebra 2 regularly. So now here's another odd middle term. Take it and divide it by 2. So 5 over 2 now gets squared. And of course, 2 squared on the bottom is 4. So we know that that's going to be the case all the time. But 5 squared is 25 for the top. So really, we could have just said, well, 5 squared over 4 for that blank. Now let's write it in parentheses squared. And what you have to do is just take the b term and divide it by 2. That's what you want in here. And again, because the sign here in the middle was positive, this binomial is positive. So that's what you're looking for. Another way to think about it, filling in that missing term of a square, right? So that's another way you can kind of start to look at it. But there it is, guys. Good luck. Let me know if you need any help. And again, the odds are just bonuses, so you'll be having some even b terms. I'll see you guys later. Have fun. Bye.